Hello students, today let us discuss the topic slip gauges. So, what are slip gauges? They are nothing but rectangular blocks of steel having a cross section of 30 mm face length and 10 mm face width. So, we can see in this figure that slip gauges are nothing but they are rectangular blocks. They are made up of steel. You can see that this is the face width here and this is the face length that is mentioned here, and they are most commonly used end standards in engineering practice. So the size of a slip gauge is defined as the distance L. Okay, so in this figure we can see the distance L here, slip gauge length, that is the distance L between two plane measuring faces. So this L will define the size of the slip gauge. So they are made up of high grade steel with a range of sizes in a set enabling dimension to build up to 0.05 mm, 0.01 mm or 0.0005 mm according to the sets chosen. So based on the sets chosen, we can design them or we can build them in different dimensions or with different sizes. So these slip gauges are made up of either steel or they can be made up of tungsten carbide because it is extremely resisting material to hard and wear. So it is a wear and hard resisting material, tungsten carbide. That is why it can be used for making the slip gauges. So these are rectangular blocks of steel and they are most commonly used in end standards in engineering. So based on the requirement, their sizes range from 0.05 mm, 0.01 mm or even 0.0005 mm. So they are made up of high grade steel or tungsten carbide because it has high hardness and it is wear resistant. So the slip gauges are first hardened, okay, to resist wear, and they are carefully stabilized so that they are independent of any subsequent variation in the size or shape. So first what they are done, they are hardened so that they will resist the wear, and they have to be stabilized and see that their size and shape do not vary. The longer gauges in set and length bars are hardened only locally at their measuring ends. So if the gauges are of very large size, they are hardened only locally at their measuring ends. So these are the measuring ends or the measuring faces. If the gauges are very large in dimension, then they are hardened only at the measuring faces. So after hardening, what they do, the blocks are carefully finished on the measuring faces to such a degree of fineness of finish, flatness and accuracy that any two such faces when perfectly clean may be rung together. That is, when we press these faces in contact with each other, keeping them perpendicular, then we are imparting a small twisting motion while maintaining the close pressure. This phenomenon is called as ringing, and this occurs due to molecular adhesion between a liquid film and the mating surfaces. So they have to be, so first they have to be hardened, and then they are finished to fine degree of finish, flatness, and accuracy, so that they can be rung together. So what is this rung phenomena? What is done in this? So two faces are pressed in contact by keeping them perpendicular to each other and then imparting a small twisting motion while maintaining contact pressure. So you have to keep the two slip gauges together at perpendicular faces to each other, and we have to apply pressure. So this phenomena of ringing, it will occur because of molecular adhesion between a liquid film and the mating surfaces. So by ringing the suitable combination of two or more gauges together, we can build up any dimensions. So we will get into details of this ringing phenomena in the later slides. So by ringing suitable combination of two or more gauges, we can build up required dimension or desired dimension. So to reduce the wear of slip gauges, a pair of protector gauge blocks are used and they are rung to the ends of the slip gauge combination. So this protector gauges blocks are made up of tungsten carbide, or it can be made up of any wear resisting material which do not wear out, and they will protect the slip gauges from wear. They are marked with the letter P on the measuring faces. So if there is a presence of protector gauge on the slip gauges, it will avoid the wear of these slip gauges. That is why protector gauge which is made up of tungsten or any wear resisting material is placed on these slip gauges, and it is marked with the letter P on the measuring faces. Now, what are the basic forms of slip gauges? So there are three basic forms of slip gauges. The first one is the rectangular form. This is used because they are less expensive to manufacture and they are used where space is limited or where excess weight is undesirable. So first one is the rectangular form. So they are used because they are less expensive and they are used where space is limited or where excess weight is undesirable. The next form is the square form. So they are preferred in certain applications, but they are very expensive. Because of their large surface area, they adhere better to each other when wrung to build long lengths. Further, they will not wear out easily. So they are preferred in certain applications, but they are very expensive. They have large surface area and they adhere better to each other when wrung together or rung together to build long lengths, and they do not wear out easily. The third form is the square with the center hole. So these gauges are inserted on the tie rods because we have to ensure that the rung stocks do not fall apart while we are handling. So these gauges are inserted on the tie rods to ensure that the rung stocks do not fall apart. So the next one is the major requirements for slip gauges. What is required for making of the slip gauges? So we know that these slip gauges are used to provide end standards of specific length by combining the several individual slip gauges. Okay, so the combination of these slip gauges depends on the formation of the bar. Okay, to a desired length, we will form the bars by cohesion between or by joining by the ringing phenomena. The individual slip gauges will be joined and we will form a bar of a desired dimension. So for achieving this, the individual slip gauges must be available in dimensions which is needed to achieve any combination with minimum number of gauges. So the first requirement says that we need individual slip gauges that are available in dimensions which is need to achieve any combination with minimum number of gauges. And the accuracy with which these individual slip gauges must be attached to each other so closely that the length of the build-up combination is equal to the added size of the individual slip gauges of the assembly. So there must not be any gaps between these slip gauges when they are attached to make the large bar. Okay, so this is the meaning. The accuracy with which we are joining them must be very high. Must be such that the length of the build-up combination is equal to the added size of the individual gauges of the assembly. So the next requirement is that the attachment of the individual gauges must be firm enough to permit reasonable amount of handling as a single unit. So when we are handling these slip gauges as a single unit, they should not get separated. That is the meaning. They must be so firmly attached. And the last requirement is it must be possible to detach all the individual slip gauges so they can be reused without any damage to their original size and the property. We must be able to detach the slip gauges one by one and we can ensure the reuse of them again. The next one is the ringing phenomena. So how does this phenomena take place? This ringing phenomena takes place when two flat lapped surfaces are placed in contact with a sliding motion. So if the surfaces are clean, they will adhere strongly when slid carefully together. So, this ringing phenomena is nothing but we are trying to join two slip gauges together. So, how we are joining them? By sliding motion. So, this phenomena is partly due to molecular adhesion between a liquid film and the mating flat surfaces, and partly because of the atmospheric pressure also. So, it has been found that the gap between the two rung flat pieces is approximately 6 nanometer, that is 10 to the power minus 9 mm. So, which has no effect on the total length. So, this phenomena is also due to molecular adhesion between the liquid film and the mating flat surfaces, and also because of atmospheric pressure. And also due to atmospheric pressure. So, the gap between two rung surfaces is 6 nanometer, which is 10 to the power minus 9 mm, and has no effect on the total length. So, this phenomena is very simple and it can be achieved easily provided the surfaces are clean from burrs. What should be done? The surfaces must be washed with the petrol or benzene or carbon tetrachloride or any other degreasing agents, and they have to be wiped clean on a dry cloth. Then one gauge is placed at right angles to the other and slid over the other. So I will show you how the phenomena takes place with the figures. So first of all, we have to know that this phenomena is very simple, and what should be done? The surfaces to be wrung must be cleaned thoroughly with petrol, benzene, carbon tetrachloride, or any degreasing agent, and then must be wiped with a clean cloth. So, as shown in this figure A, one gauge is placed at right angle to the other and slid over the other. So, here this is the first gauge and this is the second slip gauge. It is placed at a right angle to each other and they are slid in this direction. So, while sliding, you have to press them together as well, and then a twisting motion is applied until gauge blocks are lined up as shown in this figure. So, firstly, they are kept at right angles to each other and they are pressed together, and here a twisting motion is applied as shown in this figure in this direction. So, a twisting motion has to be applied on these blocks. In this way, the air is expelled from between the gauge faces, causing the two slip gauges to adhere together. So, when we are pressing them together and adding the twisting motion, the air between these two gauges will be removed and they will be adhered together as shown in this figure C. So, this is the ringing phenomena. So, as shown in the first first figure, that is A, what is done? One gauge is placed at right angles to the other and slid one over the other. So this is shown in the figure A. The figure B shows that while pressing them together, a twisting motion is applied until the gauge blocks are lined up as shown in figure B. Then the last figure shows here, because of this pressing and twisting motion, the air between the two gauges is expelled and causes the two gauges to adhere together. So similarly, even for separating these rung slip gauges, combined sliding and twisting motion should be used, and they should not be separated by directly pulling the slip gauges because it will damage the gauges. So for separation of these gauges, same twisting and sliding motion must be applied because if we pull them separately, they will get damaged. So this is the ringing phenomena of the slip gauges. The next one is the manufacture of slip gauges. So the method for manufacturing of slip gauges was developed by the National Physical Laboratory. So as shown in this following steps. So method was developed by that is the NPL. So what is the method? So the first step, the section of a high grade steel gauge block by preliminary operation. So we take a section of a high grade steel gauge by preliminary operations. So first step is the next step is the initial hardening heat treatment to increase the hardness and the wear. So next what is done? Hardening is done by heat treatment to increase hardness and wear resistance. The third point is stabilizing treatment is performed by heating and cooling the gauge blocks successively after rough grinding all over to remove hardening stresses. So stabilizing is done. So this stabilizing treatment is done by successively heating and cooling the gauges, and after the rough grinding all over removes the hardening stresses. The successive temperatures used in 4 stages are 40 degrees Celsius, 70 degrees Celsius, 130 degrees Celsius and 200 degrees Celsius. So the gauges are first heated in sand and they are cooled slowly at each stage. The successive temperatures used 40 degrees Celsius, 70 degrees Celsius, 130 degrees Celsius, and 200 degrees Celsius. So they are heated and cooled slowly at each stage. The fourth step. 8 gauges of one size are then mounted on a special type of magnetic chuck and spot ground on each face. So you can see that here in the figure A, there are A, B, C, D, E, F, G, and J slip gauges. So what do we do while manufacturing them? There is a magnetic chuck. So if this is the magnetic chuck, that is the big rectangular shape which is shown here, we place the 8 slip gauges on them, making the combination which are of same size. So preliminary lapping operation is carried out, which makes all the gauges parallel to about 0.0002 mm and within about 0.002 mm of size. So by this, they will be parallel to each other to about 0.0002 mm and within about 0.002 mm in size. The next point shows final lapping process is carried out on a solid steel chuck on which the gauges are rung in a manner as shown in this figure. When the gauges have been lapped in position, all the faces will lie on one plane, which will not necessarily be exactly parallel to the plane of the chuck. So in order to eliminate this wedging effect, one gauge in corner is removed and rearranged as shown in this figure B. So each gauge being turned end to end in the process. A little consideration of these rearrangement will show that in whichever direction the wedge may lie, there is almost equally high spot at each corner. So the gauges are taken and they are kept in a magnetic chuck. Then again they are kept for the last process or the last procedure for manufacturing of these gauges. They will be kept on a solid steel chuck. They are rung together like this as shown in this figure. When these gauges have been lapped in position, they are on position and all the faces lie in a plane which is not necessarily parallel to the plane of the chuck. So they may not be parallel to the plane of the chuck. So to avoid this wedging effect, one gauge in the corner is removed and rearranged. How they are arranging? They are taking this gauge B and they are placing it with gauge G, and the gauge which was present with G, that is J, is placed with A, and here this gauge with E, there was F which is gone with C and it in the opposite direction. Now here E has D in the opposite direction. So this will remove the wedging effect. The final lapping is carried out on a solid steel chuck. Here gauges are rung together in a manner shown in figure A. But there will be wedging effect. It is the lapped gauges will not be exactly parallel to the plane of the chuck. So to avoid it, what is done? one gauge in each corner is removed and rearranged. So each gauge being turned end for end in process as shown in figure B. So further lapping produces very high degree of parallelism and equality of size between the 8 gauges. Then all the 8 gauges are compared with the standard equal to their nominal aggregate size. So this is all about the manufacturing of the slip gauges.